All right, guys, welcome to part 2 of Math 0106. This is lesson 8, part 2 again, where last time we were working through some of these problems and I got up to number 13. So we are on 14. This is actually more of the same. So if you haven't done so already, go ahead and try to finish these problems off on your own and then compare to my work. Remember, math is not a spectator sport. You get more out of this if you actually do the problems on your own and then compare your work to mine. So we are on number 14, so we have 4 plus 10 over 11. Now, hopefully you remember that when we say 4, we're really saying 4 over 1, and hopefully you also remember that if we're dealing with fractions, we have to get the denominators to match up. So whole numbers actually may look initially intimidating, but they're actually really good, nice to get, because you just have to multiply by whatever the denominator is on the other side. So we multiply by 11, so we're going to end up getting 44 plus 10 over 11, which gives me 54 over 11. We're saying it's okay to leave it as an improper, and so there's our answer. So that is number 14. Okay. So now let's do number 15. So 15 is looking slightly difficult because it has 3 different fractions, but we still do the same thing. We're really just looking for the LCM of 8. I'm sorry, between 2, 4, and 8, which is 8. And again, you can easily see that because 2 goes into 8 evenly and 4 goes into 8 evenly. So we're going to do the same thing as we've been doing. We're going to multiply these by 4 and 4 because 4 times 2 is 8, and here 2 and 2 because 2 times 4 is 8. So this is going to give me 4 plus 2 plus 1 all over 8. Here's where the 4, here's where the 2, and here's where the 1 are coming from. Put it together, this is 7 over 8. And that's your answer. So this is for number 15. So let's move on to the next one. So for number 16, instead of addition, we have subtraction. And one thing I want to stress here, this is actually one of those things that a lot of students make mistakes with. 1/3 is significantly larger than 1/9 and 1 over 27. And so when we subtract this, we don't have to concern ourselves with it getting a negative number, or in a real world sense of getting a situation that, let's say you have 1/3 of a pizza and you cut it by 1/9, and you take out 1/9 of the pizza and you take out a 1 over 27th of a pizza. You don't have to worry about that not making sense because 1/3 is significantly larger than 1/9 and 1/27. And again, going to the pizza example makes sense. Think about cutting a pizza into 9 slices and thinking about how much that pizza versus 1/3, right? It's significantly less. So the reason why I'm bringing this up is that a lot of people see 9 and 27, and because you see 9 and 27, you think bigger. But in terms of fractions, the bigger the denominator, the smaller the number is if we're playing with positive numbers. So keep that in mind when you're working through this. What really goes on is in your mind, your brain sees 9 and 27 and thinks 9/27 is bigger than 3. But again, because it's a fraction, it's the other way around. Okay, with that being said, this problem is not going to be too bad because, again, 3 and 9 go into 27. So we're going to go times 9, times 9, times 3, times 3. And this is going to give me 9 minus 3 minus 1 all over 27. 9 minus 3 is 6. 6 minus 1 is 5. So it's 5 over 27. And there's our answer. So you can see even if you have 3 numbers or 3 fractions, it's still not that bad. Okay, so that was for number 16, and we're going to move on to number 17. Okay, so for number 17, we have 3/4 minus 1/2 plus 3/5. And again, here we're going to look for the common denominator. This one's a little tougher, right? The previous two, the biggest number was the common denominator was the LCM. Here we might have to think a little bit, so I'm going to write over here, we're going to do 5, we're going to do multiples of 5. 4 does not go into 5, so we have to do the next multiple, which would be 10. 4 does not go into 10, we have to do the next multiple, which is 15. 4 does not go into 15, getting a little nervous here, but 20 works, and 20 goes into 4, and, I'm sorry, 4 goes into 20, and 2 goes into 20. By the way, because 2 goes into 4, I actually don't need to worry about checking for 2, because every number that works for 4 will work with 2. This is why also we say even numbers are divisible by 2, right? So if it's even, it's going to be divisible by 2. Okay. All right. So here I'm going to multiply by 5 and 5. Here I'm going to multiply by 10 and 10. And remember, all I'm doing is asking myself 4 times what is 20? 2 times what is 20? 5 times what is 20? 5 times 4 is 20. So this is going to give me 15 minus 10 plus 12. I had to double check there, make sure that the numbers line up correctly. Okay, and so we're going to solve this. So I'm going to show you something that I would do. You can just subtract across. So you could do 15 minus 10 is 5. 5 plus 12 is 17, and 17 over 20. And that's not too bad. What I try to do, though, is I try to look for this to make numbers smaller. So I might do 12 plus 12 minus 10, which is 2. 2 plus 15 is 17. If that doesn't make sense, that technically is beyond the scope of this course. Don't worry about it because I'm adding negative numbers. So if you're looking at that, that doesn't make sense, just left to right and you'll be fine. But if what I just said there, taking 12 minus 10, makes sense to you to get 2 and add 15, I would advise that because if you can make numbers smaller, they're easier to add in your head. Okay, so that was the end of number 17, and now we're going to do 18. Okay, so let's look at the next one, number 18, 5 over 6 plus 2 minus 5 over 9. Again, remember that 2 is the same thing as 2 over 1. I always like to do that to emphasize the fact that I'm going to do 2 over 1. And now we're going to have to find the LCM of 6, 1, and 9. So we're going to look at 9. We're going to say, hey, does 6 go into 9? No. Then we're going to do 9 times 2, which is 18. Does 6 go into 18 evenly? Yes, it does. So there we have it. So this will be times 3 times 3. This will become times 2 times 2. And we'll get 15 plus 2 minus 10 all over 18. 15 plus 2 is 17. 17 minus 10 is 7. So we have 7 over 18. It's as easy as that. On to number 19. Okay, so let's look at number 19. Now, a lot of people, when they look at number 19, there's a little concern with 30 and 45. And if you recall from the LCM video, we talked about when numbers, they get bigger and bigger, it may make sense to look for the LCM with the prime factorization. If I take 45, though, obviously 30 is not going to go into 45, but 45 times 2 is 90, and 30 does go into 90. So it's still relatively easy here to figure it out. But if we did prime factorization, I do want to illustrate that prime factorization is not that bad in terms of doing this. So hopefully what I just wrote out makes sense, but let me go into a little more detail here. All I'm saying here is I did 30, I chose 5 and 6. Again, you may thought of 3 and 10, it doesn't matter. And then 6 is 2 times 3. 45, I think 5 and 9 is the most common one. Some of y'all might do 3 and 15. And so we have 3 and 3. So we get 2 times 3 times 5, 3 squared times 5. When we're looking at this and we say, how do I go about finding my the LCM? We take the highest power of each of the bases. So there's only a 2, so we'll take 2. There's 3 versus 3 squared, so we'll take the higher, 3 squared. And then we have, actually, let me do this in a different color. We have 5 and 5, so we take 5. And when we put this together, we get, this is going to become 9, this is 2, this is 5. Again, I'm looking for the easiest combination. I think 2 times 5, 10, 10 times 9, 90 is the fastest way, the easiest way to get to 90. And you'll get it. The only cost is that, right, doing prime factorization does take a little bit more time in this situation. Okay, so we know that the common denominator is 90 here. I'm going to erase this because I'm probably going to need more space here. So again, what I want to emphasize working through this is that you can pick whatever method you want and pick what you're comfortable with, but I normally just finding the common denominator by listing that is usually the easiest way. So we're going to multiply top and bottom by 3. I'll multiply top and bottom by 2. And this is going to give me 39 plus 16 over 90. Numbers look a little nasty, but that's okay. This is going to be, I believe, 55. Let's double check. 39 plus 16. 9 plus 6 is 15. 4, 5. Yeah, 55. So 55 over 90. Also, as I work through this, one thing that you're noticing is that if you get comfortable with your multiplication, as you work through these problems, I saw 45 and 30, and because I know multiples of 30, like 3 times 1, 3 times 2, 3 times 3, 3 times 3 is 9, so I knew that very quickly, that if I could get 45, but when I did 45 times 2, I would get 90, and then saw that worked. But being familiar with how to multiply numbers quickly in your head makes it so that when you see that situation, you can see what to do. You have a kind of like a little bit more of an instinct as to, hey, is this a good idea to do this versus that, right? Whereas if you don't know, you're kind of flying naked and you're just trying to figure out, hey, maybe I'll try this without an idea of, hey, prime factorization might really be the fastest method. So in essence, what I'm saying is the more familiar you get with this, the more likely you are to choose the better method, being better meaning more efficient, right? And that matters, because if you're taking a test and you pick a method that's not as efficient, then your propensity of making a silly mistake grows dramatically. So this isn't just a moot point. Actually, I think it's very, very, very important. You're trying to minimize problems right along the way. It's like why you hold a handrail while you walk up the stairs, right? You're not necessarily going to trip and fall walking down the stairs or walking upstairs, but you want to diminish the odds. It's why you wear a seatbelt, right? It's not like you're going to get in a car accident every time you jump into your car, but if you did, it helps to decrease the odds of something really bad happening, and that's what we're doing here. Okay, apologize. That was not an efficient way of stating that, but I think it's important to talk about stuff like that. Okay, so we know from the divisibility rules of 5, it ends in a 5 and a 10, so we can at minimum divide these by 5. We also know if we have repeating digits, it's going to become 11, so 55 divided by 5 is 11. Now 90 divided by 5, you can do this straightforward. I'm gonna show you a little trick here. So in my mind, what I do when I see 90, I think 50 plus 40, because 50 divided by 5 is easy to do, and 40 divided by 5 is just 8. So this becomes 10 and 8, and you can put them together and get 18. And if you practice this, you can kind of do this in your head pretty quickly. So I'm a big proponent of cutting up numbers into smaller numbers and dividing those. I think if you get comfortable with that, doing that in your head, it makes the problem fairly easy. But in any case, number 19 was 11 over 18. And last but not least, let's do number 20. Okay, so here we have 20, and 20 seems a little intimidating. I'm not exactly sure if we're going to have to list quite a bit of factors to figure out, or multiples, I should say, of 42 in order to figure out what goes into 42 and 24. So here, I'm definitely going to just jump straight into prime factorization. Obviously, 42 times 2 is it's easy enough to do, and it's 84. But does 24 go into 84 evenly? I'm not certain. So instead of guessing and checking, I'm just going to do prime factorization. So this is going to become 2 and 12, 2 and 6, 2 and 3. So this is going to be 2 cubed times 3. Notice that I chose 2, but I could have done 3 and 8. You technically could do 4 and 6, but I always like to try to divide by a prime. I think it makes it easier. Here I'm just going to do 2 and 21. I could have done 3, but 2 is pretty obvious. And this is 3 and 7. So this is 2 times 3 times 7. So remember, when we do prime factorization, we take the highest power of each of these. So 2 to the third times, and then we have 3 and 3. And then we have just 7, so times 7. So all of this becomes 2 to the third is 8. 8 times 3 times 7. I'm going to do the back end. That's 21 times 8. Makes it a little easier. So it's 168. So it wouldn't have taken too long in terms of the multiples to figure out what would work with, I think 42 times 4 is, 42 times 4 is 168. So if you just listed the multiples, it still wouldn't be that bad. But I wasn't certain, so I just went straight to prime factorization. Okay, so hopefully that makes sense. And we're going to get 168. So, by the way, if you don't know 24 times what is 168, my advice to you is play with the ones digit, the ones place or the units place. That's right before, technically there's a decimal here. It's right before the decimal. So I'm going to look at 4, and I'm just thinking to myself, 4 times what gives me 8? Well, 4 times 2 does, but that's too close. 4 times, what's the next one? 6, no, 7 works. Okay, so 4 times 7 is 28, and so it's probably 24 times 7 is going to be 168. Let's see. So it gives me 28, 14 and 2 is 168. There you go. So the idea is you're kind of guessing and checking to figure it out, but because you know it does go, 24 does go into 168, you know that you just need to look for that ones digit to give yourself a good estimate. It's a little bit faster than sitting there and just multiplying by adding 24, just trying 24 times 1, 24 times 2, 24 times 3 till you get there. So, or we're just randomly guessing. Okay. And then with 42, same sort of deal. We can, I just told you it was 4 earlier, and you can see that because, again, if I play the same game, let's change the color here. If I play the same game, 8, 2, 4 times 2 is 8, right? And then you can quickly see 4 times 4 is 16. So hopefully that makes sense. And we're going to multiply by 4, multiply by 4. And by the way, it doesn't matter whether, it really doesn't matter whether you multiply in front or the back when you're doing this. So notice I've been putting them in front for the most part. So you see that here. But here, 4 was kind of a big number to write, so I didn't put it off to the left. I put it on the right. So it doesn't matter. It's nobody's going to be look at you and shun you for putting it on the left or the right when you multiply by 4. Okay, so if I did this correctly, 17 times 7 should be, I'm going to just double check, yep. 17 times 7 is 119, and then 5 times 4 is 20, all right? So then we're going to solve this. My advice to you when you see 119 minus 20, realize if I did 120 minus 20, that would be 100. So it makes sense that this would become 99, and this is 168. Now, something that's pretty cool about this is if you're looking at 99 and 168, you're like, can I clean this up? Can I simplify? Can I reduce? And the answer is you can. And one thing that's kind of helpful in noticing that is if you look here, you see 2 cubed times 3 times 7, right? This is the prime factorization of 168. I mean, this is what 168 is. If we wrote down the prime factors of 168, that's what it would be, right? Well, the reason why this is cool is that it tells you that 168 is divisible by 2, divisible by 3, divisible by 7, minimum, right? So when I look at 99, I know 99 is divisible by 3, and I automatically then know that 168, that I want to do both of them by 3, right? I mean, some of y'all might be sitting there and be like, Anderson, that's a kind of a mute point because I'm looking at 168 and I know my divisibility rules that if I add them, 1 plus 6 is 7, 7 plus 8 is 15, and because 15 is divisible by 3, I know both of them are divisible by 3. And that's true, but if I had given you a number that was, let's say, divisible by 7, then looking back here and realizing that it works with that 168 is divisible by 7 tells me, hey, yeah, I'm going to divide both of them by 7. So it's not necessary in this situation, but it's a nice skill to look out for, especially if you have the work off to the side anyways. In any case, let's go ahead and do that. Let's divide through by 3 and see what we get. So 99 divided by 3 is 33 because 9 divided by 3 is 3. 168 divided by 3, I'm just going to put that in over here. This is going to give me 5, 15, 18, 56. So we have 33 over 56. Now, 33 is 3 times 11. 56 is not divisible by 3, and I hope you know why. Again, 5 plus 6 is 11 because 11 is not divisible by 3. The number is not. And an 11 obviously isn't going to work with 56 because for two-digit numbers, numbers are divisible by 11 if they repeat, right? So you'd have to have 55 would be the closest one to that. So that is it. There's your final answer. So again, want to emphasize that if hopefully you were able to do these problems on your own, though maybe watching this video helps you to see more clearly how to solve some of these more sophisticated problems. But at the end of the day, what I really want you guys, but if you didn't understand initially, I should say, then what I want you to do is make sure you work back through. Actually, before I go, I want to do one more example. Okay, so this is the last one I want to take a look at. 11 over 24 plus 3 over 36 plus 15 over 48. This is actually found on the review. And the reason why I want to talk about this problem is this is a sort of problem that you may see on a final, and you need to make sure that you see what's the simplest approach to this, because if you don't see the simplest way of doing this, you may be consumed in time and kill yourself in time by focusing on one question. And the big issue here is that when you are solving a question like this, what you always want to do first is simplify. Why? Because we know that the bigger the number is, we're looking at 48 here, writing multiples of 48 until we find the one that works with 24 and 36 is going to be quite painful. Why? Because it's difficult to divide by 36 and 24. So instead, let's divide through and see if we can make numbers smaller. So obviously 11 and 24 we cannot, but both 3 and 36 are divisible by 3. So we can get 11 over 24 plus 1 over 12 plus, and here we can divide both of these by 3. So this would be 5 over 16. And 16 times 3, I would memorize that. That's very common. I see that a lot. Okay, so with that, now we're going to look for the LCM with 24. So the nice thing is, if I'm looking for the LCM with 24, is that 12 goes into 24. So I don't have to worry about 12, I just have to worry about 16. So does 16 go into 24? Clearly not. But 24 times 2 is 48. And we just said 48 times 3 is, or 16 times 3 is 48. So we know that 48 is going to be our LCM. So now I'm going to just multiply through by 2 and 2 to get to 48. I'm going to multiply through by 4 and 4. By the way, you see that 12, if you double 12, you get to 24. So it makes sense that you'd multiply by the doubling of 2, which is 4. And with 16 times 3. As we said earlier, it doesn't matter if you put the multiplication on the left or the right. It's more for your visualization than anything else. So this becomes 22 plus 4 plus 15 all over 48. Let's clean it up. 22 plus 4 is 26 plus 15 all over 48. And now what we're going to do is put 26 and 15 together. That's going to give me 41, and that's going to be over 48. So that's something that you would probably see on a final or a big test. So you want to be comfortable with that. In any case, now I'm done, and I will see you guys in the next video.